Next example, we do have a square root in the denominator. Difference is that square root in the denominator this time, we can't just say, last time I just said multiply times root 3, multiply by itself. That would give us a root 9, giving us a 3 in front. But the problem is when I distribute, all it's going to do is make an x root 3. All it's going to do is throw that square root on the back. Reason being, this is why we talked earlier about when we had that difference of squares. Remember what got that canceled was when I had a square root plus an x. Well, what if I change that sign? If I make it square root of 3 minus x, that's what's going to get everything to cancel, just like my difference of squares. Has a name? It's called a conjugate. Conjugate is what, when I multiply by itself, gives me that number that's going to cancel. And what I do to the bottom, I'm still going to do to the top. Well, top's uneventful. 4 times root 3 is 4 root 3. 4 times negative x is negative 4x. Uneventful. Denominator, I'm going to have to FOIL. Root 3 times root 3 is root 9, which ends up just giving me 3. Root 3 times negative x is negative x root 3. X times root 3 is plus x root 3. X times negative x is negative x squared. Middle term's going to cancel. That gets rid of all my radicals, and what I have is 4 root 3 minus 4x all over 3 minus x squared. And what I end up with is all of my radicals are out of the bottom. I do have that radical at the top now, but that doesn't matter when I talk about rationalizing the denominator. Now, the big difference between the ones earlier were when I just had that monomial. When I just had the one term, yeah, multiply by itself. But the problem is when I have those two terms, that's when I have to multiply it times the conjugate. That's when I have to change the sign. And changing the sign is what gives that difference of squares canceling, because the squares will even cancel out the square roots.